Okay, so our final part of user-defined functions, we're going to talk a little bit about scope and overloading, particularly as they relate to void functions, but really for any type of function. So when we looked at the void functions, those were functions that did not return a value versus the ones we saw in our first that returned a value. We could do two different types of things with our parameters. One, we could pass them by value, which is where we make a complete and original copy of the original, and the other is passed by reference, where we modify the original back in main. Pass by reference is really useful for returning multiple values, doing things such as getting input, and pass by value is good when you don't want to modify the original. So a bit more about scope. When we declare things inside of a function, the function, that variable is a local identifier. And so it's a local variable only within the function. If we declare something outside of every function definition, we get a global identifier or a global variable. So, if we declare, like, say, variable max inside a function, then it's a local identifier and we can't see max inside of main. And you can get around this by declaring things outside of main, and those are global variables. And if you declare them above main, then any function, including main itself, can make use of it. Now positives, every function can see it, you can use it, and you can modify it. You also get bonus points for rebelling against the norm. So throw in a goto or two as well, and make some old spaghetti code from the 1970s. Kind of the negative is you get something called a side effect, which is where the variable can get modified accidentally. So you end up with unintended consequences. It makes it really hard to debug programs. If you go back and you look at some of the source code that used to be published in magazines back in the 70s and early 1980s, it's a wonder that we got any of it to work whatsoever. It was completely disorganized. So basically avoiding these global variables and go-to statements allows us to better organize our code, and it makes it easier to debug. At first you may say, well, it's easier, if I can do it anywhere. And hey, if that's the only way you can get it done, get it done. It's better to have code that works and is a bit ugly than something that's beautiful and doesn't work. The other thing is you can't define one function inside of another like you can with languages such as JavaScript. However, you can use multiple blocks, which are segments of code set off by the braces. If you're using nested blocks, the variable is only available from the point of its declaration to the end of the block in which it was declared. You don't have to worry about this stuff too much until you take programming languages, but just be aware that there is scope. If you declare it in the far interior block, you're not going to see it in the block that's immediately outside of that. Static and automatic variables. The automatic variables are the ones you've been using up until now. When the block or function ends, variable gets deallocated or reset. So if we declare max inside a function, when the function ends, then max gets deallocated or reset. If you want to keep the variable throughout all executions of the function, you can use a static variable. For example, static int number of calls, and that keeps track of the number of times you called the function. They still have local scope, so you can still only see them inside the function, but you don't deallocate them. And then you can also do overloading functions. Or overloading for functions. And we talked about a function having a signature, which is the name of the function followed by its parameter list. And so you can have two functions with the same name as long as they have different parameter lists. So for example, this is okay. Double area with radius, and then double area with length and width. If we wanted to calculate the area of a circle, we'd use the first one. If we wanted to calculate the area of a rectangle, we would use the second one. The functions need to have different signatures. Again, so those have different signatures because there's a different parameter list, even though they have the same name. Now, if we wanted double area with length and width, and then one int area with length and width, that's where we would get into trouble, because those have the same signature, same name, along with the same parameter list. And so if you called area, the compiler wouldn't be sure whether you were intending to get a int or a double back. So if you're going to overload or have two functions with the same name, they need to have different parameter lists. You can't just differ them by the return type. So for functions, basically these help us divide the program into manageable subtasks. And we have the predefined functions that you get in different libraries in C++. And then we can write user-defined functions to do customized things that we want to do. We have the traditional value returning functions, and then we have procedures that are characterized as void functions. The variables defined in the function heading are called the formal parameters, and expressions, variables, or constant values in the function call are the actual parameters. The function heading and the body of the function are called the definition of the function, and a value returning function returns its value via the return statement, and return is a reserved word in C++. Prototype or declaration is the function heading without the body, and then the user-defined functions execute only when they're called. So you have the declaration, the definition, and the invocation. And then for our void functions, they don't have a data type that they return. Two types of parameters that we saw. There's pass by value, which receives a complete and independent copy of the actual parameter, and then reference parameter, which modifies the original backend main. And then variables declared within a function are called local variables, and declared outside of every function definition are called global variables. And then we saw automatic versus static variables, and the automatics are the ones that we've been used to using so far. The memory gets allocated on the function block entry and deallocated on the exit. Static variable is a variable for which the memory remains allocated throughout the execution of the program. So you can use to keep track of how many times you called a function. C++ functions can also have default parameters, and that's treated in chapter 6 of the textbook. So thanks so much for watching.